Example 21 on page 34. For the series 3 plus 9 plus 27 plus dot dot dot, so it's going on forever, what is the minimum number of terms? So how many terms does it take? Needed for the sum to exceed 1,000. To exceed 1,000, be bigger than 1,000. All right, so let's think about our geometric series tools. We have these tools down here, the general term formula, the sum to a certain term formula, and the sum to infinity formula. Well, we're not summing to infinity, but we are summing. Okay, so we're going to need to use either one of these formulas. So let's get started. Now, in the textbook, they show you how to complete this with a graphing calculator because it's in chapter 1 and supposedly you haven't learned logarithms yet. But you actually know how to solve this on a paper 1 exam as well, because with no calculator, because you know how to use logarithms. All right, but if you do use, we're going to talk about what the equation is first. All right, so sum these up. So let's talk about the SN formula. I'll choose this first one. U1 r to the power of n minus 1 all over r subtract 1. All right, what do we know? We don't know n. Okay, so Sn we don't know. U1 we know is 3. And r we can calculate because 9 divided by 3 is 3. 27 divided by 9 is 3. Okay, so therefore r is 3. So r is 3, power of n, subtract 1, all over, r is 3 again, and here. Okay, let's simplify it. So we have over 2 there. All right, now, so this is the equation, an equality. We want to know how many terms does it take for this to exceed 1,000. All right, so instead of having an equal sign, we're going to have an inequality, and we want 1,000 over here. We want this to exceed 1,000, so therefore we would put the inequality in that direction, where this side is bigger than 1,000. All right, so we want that sum to be bigger than 1,000. How many terms does it take? We need to solve for n. On your graphing calculator, you can graph this side of the equation. If 1x equals 1,000, you can graph this side of the equation. When you do that, be careful. Make sure that you use an x instead of an n on your graphing calculator, and you use your cursor to move over so that this -1 doesn't stay up in the exponent. It's not part of the exponent, is it? And when you do that, and if you zoom in or change your window, you will see that we have 2 graphs there, the straight line, obviously, y equals 1,000, and then your exponential curve. Now, where they intersect is what we're looking for the answer, and that intersection for the x coordinate is 5.92. All right, which would be what we're looking for. So graph GDC, you would say, you might plot a little graph to show that you found that point of intersection, 5.92, and whatever the y coordinate was. Okay, so there's your little plot. And now we need to think about, okay, well, what does n have to be equal to? Because n is the position in the sequence, so we know that n always has to be an integer, a positive integer, because it is that position in the sequence. All right, so do we need to go to 5, n is 5, or do we need to go to n is 6? So it won't always be that we're rounding properly at this point. We have to actually think about the question. Minimum number of terms needed to exceed 1,000. So if we were able to have 5.92 terms, then that would equal, this would equal 1,000. So therefore we need n to be 6 in order to exceed the 1,000. Okay, you could try that out on your calculator, part of your calculator. You could try 3 to the power of 5 here, if it's a calculator question, and see if it's bigger than 1,000, and then try 3 to the power of 6 here with this whole whole side of the equation, see if it's bigger than 1,000, just to confirm. So if that was a calculator question. All right. If it's a no calculator question, you also need to know how to do that. So starting from this inequality, let's work with it algebraically. We could multiply both sides by 2,000, by 2, sorry. And divide both sides by 3. And now add 1 to both sides. Okay, here's where you're going to start to use your logarithms. You guys can do this. We need to solve for an exponent. That's why logarithms were invented, to solve for exponents. That means we're going to need to log both sides of the equation. It might be easier to put this all as one fraction first. So this would be plus 3 over 3. So 2003 over 3. That'll be easier. Now, we could rearrange into a log statement, or we can log both sides of the equation. When I'm dealing with inequalities, it's best to log both sides of the equation so that you make sure you have that inequality facing in the correct direction. So logging both sides. Sorry about that background noise, guys. Okay, law number 3 tells us we can bring that exponent down in front there. And I'm going to trade sides with everything, which means also my inequality changes directions, because I like to have my unknown on this side. And that's good notation as well. Now to get n by itself. Divide both sides by log 3. And when we poke that in our calculator, we're going to get 5.92 as well. Okay, same answer as we got graphically over here. Okay, then using the same reasoning, we know that n has to be bigger than 5.92. Okay, so therefore, so in this situation, it actually helps us know for sure that we're going to be 6, because we have n is greater than 5.92. So we know n is equal to 6. Again, you could check by plugging 6 back in here to make sure, or back in here, and checking for 5, plugging 5 back in here. You could check your answer as well.